In the previous lesson, I showed you how to use permissions with the DRF. In this lesson, I'm going to show you how to use serializers that are not associated with a Django model. Up until now, all of the serialization that I've shown you has been associated with a Django database ORM object. You don't have to do that. You can create a serializer from scratch, and it doesn't have to serialize something from Django. You do this by inheriting from the serializers.serializer class and combine it with serializer fields. Serializer fields are similar to Django model fields. You can explicitly create a serializer specifying field by field. It doesn't have to be based on that ORM. In this lesson and the next lesson, I'm going to use the same app, which is a new one called Vehicles. Like always, if you're coding along with me, you'll need to add vehicles to your installed apps list. You'll need to update your URLs file to include vehicle.urls to pull in anything defined there. And then follow along with any models, serializers, views, and URLs that I show you. For this particular lesson, there won't be anything to migrate. I'm going to create stuff inside of the models space, but it is not going to be Django objects, so you won't have to do the make migration and migrate. Because I'm going to be using the same vehicles app in this lesson and in the next lesson, and I'm going to be creating multiple models, in order to be a little more organized, I'm going to switch over from using a models.py file to a models directory. If you haven't seen this before inside of Django, the mechanism's more or less the same. Instead of creating the models.py file, you create a directory and then create files inside of it. There's one extra step that you have to do to get all this to work, which I'll show you in a second. Inside of the models directory, I've created a file called tools.py, and inside of that, I'm creating a regular old Python object. This object has a couple of attributes, one called name, the other called make, and all I'm doing inside of the initialization is assigning those to the object. So that that file I just created can be read from the models as a module, I've had to create a _init file, and I'm going to import that tool object inside of it. Now for the serializer. In order to keep the code nice and clean, I'm going to use a serializers directory similar to the models directory. And so inside of the serializers directory, I'm going to create tools.py, which corresponds to the tools.py file inside of the models directory. Here's my generic serializer. Notice that it's inheriting from just serializer instead of model serializer. I'm specifying each of the fields that I'm going to serialize, and I specify one field for each of the attributes of the tool object. Both of these are char fields, which, similar to Django model char fields, contain text and have a max length in this case of 50. Continuing on with the pattern, I've created a views directory, and inside of that, I've created tools.py. For tools, I'm creating a single view that just lists the tools to give you the idea of how this serialization works. On line 8, I'm using the API view decorator in the exact same way as one of the early lessons. And line 9, I'm creating the definition of the list tools view. Line 10 through 13, I'm creating two tool objects. These are just generic Python classes that have been instantiated as hammer and wrench. From line 15 on, this method is no different than when it is a Django object being serialized. You create the serializer, you pass in the thing being serialized, in this case, a list of the tool objects. Because it's multiple objects, I'm setting many set to true. And then I create a content dictionary that consists of the serialized data and pass it into a REST response object. Finally, to make it accessible, I need to add list tools as a path, pointing it to the view. To demonstrate this view, I'm going to use the browser and point it at the web interface. Going to the list tools view that I just created. And like before, you get back the same kind of interface showing the serialized data. You can serialize anything you like. It doesn't have to be a Django object. This gives you a fair amount of power. You can serialize the things in your database, or if you want, you can create your own as needed by your application. In the sample code, I showed you how to use the char fields. There are a large number of fields provided by the DRF. There are fields for Boolean, a long list of string fields. Most of these are similar. What changes is the validation. So for example, the IP address field is still just a string, but the validator makes sure that the string is formatted as a valid IP address. There are 3 numeric fields, fields for date and time, and 2 fields that allow choices of predetermined selections. There are fields for uploaded files, composite fields, which hold groupings of other things like dictionaries or nested JSON, and specialty fields like read-only and hidden for your forms, or the serializer method field, which is a special field that is read-only that gets mapped to a method inside of the serializer. Every time the field is serialized, that method gets called, which allows you to run arbitrary code anytime serialization happens. If all of that's not enough, you can always write your own. But before you do, you should check out whether or not what you are trying to dream up has already been done for you by someone else. There are plenty of third-party libraries out there that contain other kinds of fields that you might find useful. When you instantiate a field, you can pass it arguments to control how it behaves. Some of the arguments are whether or not the field is read-only, write-only, required, what its default value is, whether it allows null, what the source attribute of the field is. By default, the serializer class uses the name of the field to look up the corresponding field in the object being serialized. If you need to rename this, or there's a reason that mapping won't work for you, the source argument allows you to specify where to look something up. You can specify validators, similar to Django's model validators, that determine whether or not the values in the field being serialized are valid. And then finally, error messages, label, help text, initial, and style are all arguments you can use to specify the presentation. Some of these are specific to certain kinds of renderers. For example, if you were using the HTML renderer, the style argument can pass in CSS information to tell the template how to style the field being rendered. As you've probably surmised, the model serializer that I've been using up until now is built based on top of all these concepts that are already here. The serializer is the beating heart of the DRF. It's all about how you get that payload and how you use it. For more information on how fields work and how to use the arguments that go with them, see the Fields section of the API guide. So I've shown you how to serialize things and how to specify specialty fields. In the next lesson, I'll show you how to do nested Django ORM objects. In the previous lesson, I showed you how to use a serializer with a plain Python object. In this lesson, I'm going to show you how to deal with related objects and nested serialization. The DRF provides ways to serialize related objects in your ORM. Objects that refer to each other by foreign keys can be identified by an ID. You can also nest serialization by having related objects contained within one another. This time around, I'm going to continue using the Vehicles app from the previous lesson. You can follow along with the new models, serializers, views, and URLs files as shown. If you desire, you can create an admin.py file to go along with the models that are there, or use the one in the supplementary materials. Don't forget to run make migrations and migrate as necessary to get your models into the database. And of course, you'll want some data to play with. You can either use the admin or the load data command with one of the fixtures in the supplemental materials. Like in the previous lesson, I'm going to use the models directory and create a file called vehicles inside of it. The vehicles models file contains two Django definitions, one for a vehicle that has a single field name, and one for a part that is related to the vehicle. Each part has a name and a make, and has a foreign key onto the vehicle, so there will be multiple parts in the vehicle. Because I'm using the models directory, I need to update the dunder init file in order to import the vehicle and part so that Python can find these objects. And here's the serializers file. First off, I want to serialize the vehicle. Except for line 18, everything here is what you've seen before. The vehicle serializer inherits from the model serializer. On line 21, you indicate that this is serializing a vehicle object. On line 22, you list those fields that you're interested in. Line 18 is what's different here. I want to nest the part objects inside of the vehicle object, and in order to do that, I'm going to add a new field called the part serializer. Because vehicles are related to parts through a part set, the field name here is part set. This allows for us to automatically run the query that relates the vehicle to the part. Because there could be multiple parts for each vehicle, I'm setting many to true, and in this case, I'm going to set read-only to true as well. The reason you do this is so that if you create a new vehicle, you don't have to specify the parts that go with it. You can just create the vehicle on its own. You can decide for yourself, based on your construction, whether you want to create things like parts separately from the vehicles or do it with a post containing a nested object. The part serializer is similar to what you've seen before. It's based on model serializer, the meta information points it at the Django part module, and the fields listing lists those fields that are going to be included in the part. Additionally, I've added another field here, which is a custom field called serial number field. The serial number field is going to create a custom serial number based on other attributes of the part. Notice that I'm using the source argument for the serial number field. Normally, the DRF looks for the name of the field and uses that to look up the related value inside of the object. The part object has no field named serial number, so the DRF has no way of looking it up. The argument to source maps this lookup. If I wanted to point this at an existing field inside of the part, I could set the value of source to that field. By setting it to asterisk, it tells the DRF to just use the field serializer and set the value to whatever the custom field returns. And finally, to tie it all together, here's the serial number field. This is a custom field that inherits from the Serializers field object and implements the toRepresentation method. When called, the representation takes a value of the thing being serialized, which in this case will be the parent, the part, and then lines 7 and 8 take information of that part and return a string, which in this case is based on part of the make field and the ID of the part. Each part that is serialized will include a serial number field. Each of those fields will call toRepresentation. The make and the ID of the part will be combined into a serial number and returned into the serialized object. Now to create some views for the vehicle and part objects. Like before, I'm creating the vehicles.py file inside of the views directory. Line 12 declares the vehicle viewset. Line 8 declares the part viewset. Both of these specify the serializer that they're associated with, and the only thing I've done a little different here is shown you a shortcut for creating your query set. Line 15 and 16 you've seen before, which is implementing the getQuerySet method of the vehicle viewset. It returns all vehicles. Alternatively, you can do the same thing by setting the querySet attribute like I've done in line 10. If your query set is simple, like all objects, the querySet attribute is the better way to do this. If determining your query set is more complicated, like I showed you when filtering the restricted values of books with Indie, then you'll need to use the getQuerySet method instead. Here's the vehicle's URLs file. I'm creating a new router, registering the vehicle viewset and the part viewset, and then including that in line 12 in my URLs path. Here I am in the browser. I'm going to visit the vehicle's URL. This time I've done something that I haven't done in a while. I'm visiting the vehicle's base URL because the router has registered multiple URLs inside of it. When you hit the base URL, the router shows you all of the possible children. This is a convenient way of getting meta information about what your interface provides. Unfortunately, it only works with the router, so the list tools method that I created in the previous lesson doesn't show up here. It's still there, it just doesn't show up in this listing. But for those things that are created with the router, you can do this automatically. This in and of itself is an argument for always using view sets and using your router so that you can take advantage of this meta information. I'm going to click on the parts listing, and here you have the data that I loaded before, 2 parts. If you were paying close attention when I showed you the serializers, you would have seen that I didn't include the ID field this time. I include URL. What's URL? URL is a special DRF field that returns the URL that specifies the object. This is actually a better alternative to using the ID. If you have queried this and you have the URL available, you can use that URL to do patches or puts or deletes afterwards. This means you don't have to hard code the URLs for your objects inside of your application. This is definitely a better way to go. There are a couple situations here which you have to do some extra work to get this URL, but in the vanilla mechanism that I've just shown you here, it more or less comes for free. I'll show you the exceptions in the next lesson. Because I'm in the web browser, I can just click straight on one of these URLs, and now I can see the detail information for the part that is in the database. I'm going to go back out to the API route, and now I'm going to click on the vehicle's URL. Let me just scroll down here a little bit so you can see all of this. The payload for the vehicle's URL contains one vehicle, which is the U26 Werfler, and that vehicle contains a part set. The part set is an array containing all of the parts that are associated with that vehicle. This is nested serialization. This is another good reason to use the URLs when you're referencing these objects. Now you've got both the vehicle and the part information available to you in the payload. If you want to change the vehicle, you can use the vehicle's URL, and if you want to change the part, you can use the part's URL. That's how you do nested serialization. In the next lesson, I'm going to dig more into views and view sets and how you can specify more actions over and above the standard HTTP methods. In the previous lesson, I showed you nested serialization. In this lesson, I'm going to show you more about view sets and how to do custom actions. A common pattern in the REST world is to declare an API that includes multiple objects. Up until now, the view sets and the routers you've seen have been object-specific. If you were going to be creating a single-page web application, you might want one REST call that includes all of the objects that you want back. So it would contain a dictionary, and the dictionary would then have keys for each type of object that's coming back in your page. The view sets methods that I've shown you up until now have been object-specific, so that technique won't work in this case. Instead, I'm going to start by showing you how to declare a view and nest those multiple serializers inside of it. New lesson, New app. This time I'm going to create a new app called API. As always, with a new app, you need to install it in the installed apps listing, add the path for the app into the URLs file, and just to throw you a curveball this time, I'm going to add a little wrinkle. It's a good idea to include a version number in your API path. This allows you to do backwardly incompatible changes with your API by declaring a new version number while maintaining backward compatibility while someone hits the old URLs. An easy way of doing this is inside of the path declaration inside of your URLs file. I'll show you what I mean in a moment. As before, if you're coding along with me, the changes to the views and URLs files will need to be done in conjunction. For the moment, I'm going to be using the data that's already in the database, so you shouldn't need to do any migrations this time. Here's the new view that I'm going to include inside of my API app. Let me just scroll down. The view starts on line 12 with the API view decorator indicating that this is going to be a get view. This view is going to include two different types of information, both the doctors in the person objects and the vehicles. For a little variety, this time I'm changing the query set that's being serialized to be just the doctors, so I'm filtering on anyone with the title doctor. And one other complication arises here as well. I hinted at this in the previous lesson. You may recall that the vehicle serializer uses the URL field. In order to properly populate the URL field, the serializer needs to be aware of the request. When you use a view set, the view set does this automatically for you. Because I'm not using a view set here, I need to pass extra information into the vehicle serializer so that it can see the request object. This is done through the context parameter. The context parameter is similar to the context parameter that you would use in a Django template. It's a dictionary containing, in this case, just the request field. So the serializer includes the vehicles being serialized. Because it's multiple vehicles, many equals true, as well as the context that includes the request object. The serializer then uses the request object out of the context to construct the hostname inside of the URL so that you can get a fully qualified URL inside of the serialized payload. On line 23, I'm using the person serializer to serialize the doctor's query set. Notice that what goes in the dictionary is actually the data attribute. So I've shortcut here. Rather than creating an object called the serializer and then calling data on the object, I'm just doing it directly on the constructor in one line. Then on line 24, I serialize the vehicles like you've seen me do before and return all of this inside of a REST response object. Inside the APIs app, I create an URLs file and I register the listing that I just created. Notice that I've named the path v1 listing. This is me versioning the API. In the future, if I were going to create a new, backwardly incompatible listing, I could continue to use the old code under v1 and create a new path under v2. This allows me to deprecate an old API without removing it yet, maintaining backward compatibility for my users. In a window off screen, I'm running the Django development server, and here I'm going to hit it with curl. Version 1 of the API, piping it through the JSON pretty printer, and there's the results. Let me just scroll this back up so you can see everything. The return is a dictionary containing the field doctors and the field vehicles. The doctors field contains an array with all of the doctors, and the vehicles field contains an array with all of the vehicles. Scrolling back down, as before, the vehicles includes the nested part set inside of it, and notice the URLs being used in both the vehicles and part objects. Because I used a view instead of a view set that time, I'm not able to register the view with a router. As a result, you don't get the meta listing of all of the possible views in the root path. But what if I wanted it? Well, you can do anything with a view set that you could do with a view, so this is possible. Here's a new view set that I've added to the views file. I'm not doing anything here that you haven't seen before, I'm just doing it in a slightly different format. The declaration of the class of the doctor's view set inherits from two classes. The first class is the generic view set. Because this is a view set, that kind of makes sense. The second is a mixin. This mixin indicates which actions, and therefore which HTTP methods, will be supported by this view set. In this particular case, all I'm including is the list. So this view set will only support listing objects. For each mixin that you include, you will have a corresponding method. For the list model mixin, I have the list method. Inside this list method, I'm not doing anything you haven't seen before. I'm serializing the doctors, putting those inside of result, and returning a REST response. So here's the new API's URLs file. Since I'm now using a view set instead of a view, I use the router to register it, and I include all the URLs provided by the router, in this case it will only be one, under the v1 path listing, giving me version numbers for my API. Once again, hitting the dev server with curl, and pretty printing it. And there's the result. I'll miss you, Sir Connery. The DRF provides an entire hierarchy of ViewSet classes for your use. There's the base ViewSet class, the generic ViewSet class that I just showed you, which adds the QuerySet attribute, the getObject and getQuerySet methods, the model ViewSet that you've been using in the lessons up until now, and there's also a read-only model ViewSet that is a model ViewSet but doesn't allow changes to it. Several lessons ago, when I introduced ViewSets, I showed you this base class. It's probably worth reviewing now. The base ViewSet declares 6 methods that correspond to the actions that are being performed in REST. List lists objects, create is for a post, creating an object, retrieve is to get a specific object, update and partial update are for updating existing objects, and destroy is for deleting an object. Each of these methods is declared inside of a mixin. It's done this way so you can mix and match the mixins and create a ViewSet with only those methods that you wish to support. The mixins are create, list, retrieve, update, which provides both update and partial update methods, and destroy. Essentially, there's a mixin for each one of those methods I just showed you in the base class. Additionally, if there's something that you want to do that isn't covered by one of those actions, you can declare your own. You do this by adding a method to a ViewSet subclass and then decorating it, indicating that it's an action. One of the more common purposes for this is mass operations. REST, by default, doesn't support the change of more than one object at a time. For example, if you wanted to be able to delete multiple objects, you would have to make multiple calls. Instead, you can create an action, which is mass delete. Let me show you how to do that right now. Here's my mass delete ViewSet that I'm adding to the views file. First off, I have to inherit from generic ViewSet so that this is a ViewSet. Secondly, this ViewSet is only going to support deleting objects, so I'm going to use the destroy mixin. Inside of the class, I'm creating a method called massDelete, and I tell DRF that I want this to be an action available in the REST API by decorating it with the action decorator. I'm passing 2 arguments to the decorator. The first is detail equals false. This tells the DRF that the URL to be used with this action does not include an ID. Because I'm going to be deleting multiple objects, I just want a regular URL. I don't want /3 on the end of it. Secondly, I'm passing in a list of the HTTP methods that I'm supporting in this action. In this case, it's only delete. Because I'm deleting more than one thing, I somehow have to get multiple IDs up to the server. There's different ways of handling this. I could use get with query parameters, or in this case, what I'm showing you is using a post with a string inside of it that is comma separated. When this action is called, I will process the post field named IDs and split it on any commas inside of it. Each value that is found is assumed to be the ID of an artifact that needs to be deleted. I fetch that artifact and then call the delete method on it. Finally, because there's no payload that I want to return, I just send back an empty response object. And here's the updated URLs file. You'll need to register the massDelete artifacts ViewSet with your router, adding it to the already existing doctor's registration. Let me run a query just to show you what data is available for the artifacts before I delete anything. And there are my 2 artifacts. And now I will call massDelete. I specify $X delete so that I use the HTTP delete method with curl. And the -d parameter shows the post fields that I'm going to be sending in of 1, 2. Notice that the URL is a little weird that you've got the massDelete twice. This has to do with how the router constructs URL names. It's based on both the class name and the method that is attached to it. There are things you can do to modify this, but you kind of have to jump through hoops. It's easier just to accept it as it is. Finally, to show you that this worked, I'll run the get again. And object 1 and 2 have been deleted, so there's nothing left. Next up, I'm going to leave Fedora behind and show you a new sample application that's almost a single-page application to show you how this works in the real world. In the previous lesson, I showed you how to add actions to ViewSets. In the next 2 lessons, I'm going to run through a single-page application and how you could use the DRF to help you build one. Single-page applications have become a popular way of building things on the web, and REST is a common protocol to be used with these SPAs. Single-page applications are split into a front-end and back-end. Django can be used for traditional web or as the back-end for an SPA. Your Python code on the server side includes managing any sort of business logic, and then you can use the Django ORM and database for storage. On the front-end side, there are plenty of frameworks out there to help you build SPAs. Vue, React, and Angular are some of the more popular ones. To demonstrate how the DRF can help you write these kinds of applications, I'm going to show you a small SPA. The S is a bit of a lie. I'm actually going to build 2 pages. The first will be a traditional web one that just lists a series of schedules, and then the second will be a wholly contained timeline editor, which allows you to edit the timelines associated with those schedules. I'm going to be using the Vue.js library to do this. Vue is a model view JavaScript frontend that uses declarative rendering. What that means is you pass it some JSON, and you apply HTML templates, and as the JSON changes, Vue automatically updates the templates. If Vue interests you, you can find out more about it at its homepage here. In addition to Vue, I'm going to use a couple of libraries that I've written myself. They're open source and available on PyPI, so if you find them useful, go for it. The first of the 2 libraries is called Django All. It's kind of a catch-all library for me. It contains a bunch of tiny little pieces of code that I've used over and over again in different Django applications, but none of them were large enough to warrant their own package. One feature in particular that I'm going to use is called a ranked model. The ranked model is an abstract Django model that manages ordering of objects. If you'd like to see the source code for Django All, it's available on GitHub. I'm also happy to take bug fixes and contributions. Feel free to submit a PR. Django All has been tested in production code, but nothing at a huge scale yet, so I don't promise it won't fall over. I can't say the same about the next one. Django Bootstrap Models is a series of modal dialogues in Bootstrap and includes REST-specific dialog boxes. This one's also available up on GitHub, but unlike Django All, this has only ever been used for prototypes. It's probably okay, but caveat emptor. So here are the pieces of the schedule app. On the data side, there's a Django app called Timeline with a models file inside of it. It declares 2 objects for the ORM. The first is a timeline object, which really is just a container for entries in a schedule, and the second is the entry itself. The entry contains a description and a time length. There's another Django app that's responsible for the REST API. Inside of it, you'll see serializers.py containing a serializer for each timeline and entry, a views.py file containing a view set for each timeline and entry, and then additionally another view called changeRank. The entry object inherits from Django All's ranked model class. This is what specifies the order of the entry inside of the timeline. Ranked model has logic inside of it that ensures the ranks are consistent if one of them changes. This logic is done in an overridden save method. Unfortunately, the DRF's update methods don't actually call an object's save, so the side effects that are done as part of ranked model's save method will not get called if you make a change to the rank through the REST API. So as a result, I've written an additional view called changeRank, which specifically calls the entry's save method to ensure that the rank reordering happens properly. Here's how things work when a user hits the application in the browser. First off, you visit the timeline page. That hits a view on the Django side. That's inside of the timeline app in its views file. The view is called edit timeline, and it renders a template called edit timeline. That template contains HTML as well as the Vue.js components. The Vue.js components initialize, and then as part of the initialization, the Vue component will make a REST call to fetch the timeline that's being edited. That REST call goes to the API on the Django server and hits the timeline view set. The timeline view set serializes the timeline, which then serializes nested entries, and those are returned back to the browser application as JSON. That JSON is then used by Vue.js and its internal templating mechanism to present the actual page. Inside of the client application, there are a few things you can do. The first would be to add a new entry. When that is triggered, Vue.js calls a method on a form. That form is a Bootstrap model form. The method is showCreate. ShowCreate takes a REST API URL, in this case, the one for entries, and some data for the entry that is to be created. The ID of the timeline and the rank are set by default. The ID of the timeline is the parent timeline for this page, and the rank is set by default to one more than the highest ranking item on the page at the moment. A form is displayed. When the user submits the form, the data from the form, as well as the hidden timeline and rank fields, gets sent to the server by showCreate. This is a REST call. That hits API v1 entries, creating the object on the server, which responds back with JSON of the object created, and that's populated inside of Vue.js. A similar process happens when an entry is edited. The same form is used, but this time it calls a method called showPatch. ShowPatch takes 2 parameters, the URL of the object being edited, This would be the entry object inside of View.js that's actually being edited and its URL attribute, and then the data from the actual entry object. ShowPatch shows the same form, pre-populated with the data from the entry object. The user can then make changes. When they save the form, Bootstrap Modals makes a REST call. That REST call is to the entries object with the given ID, sending up the fields from the form and patching them on the server. The REST call returns the resulting changed data, and View.js is populated with the change, and the change is reflected on the screen. The other possibility is one entry is dragged around on the screen, changing its order. This is done through a library called ViewDraggable. ViewDraggable has a hook on it for the onMove event. The function that is called in the onMove event figures out what entry has been changed and calls through REST the change rank call. This passes in the ID of the entry being changed and the new rank. That calls the specialty view that ensures that entry's save method gets called, which makes sure that all the ranks are set correctly. And in this case, because multiple ranks may change, the change rank view returns all of the entries for the timeline. View.js then updates its copy of it based on the JSON returned and then updates the screen. I hope this gives you a little bit of a glimpse of how these things work and how you can quickly slap together some items with very little code on the server simply by using something like the REST APIs you've seen in this course. Next up, I'll take what I just showed you in pictures and show it to you in code. Just as a little warning, it'll be both Python and JavaScript to show both parts of the code. Be prepared. In the previous lesson, I showed you an example of an SPA architecture for the sample SCED application. In this lesson, I'm going to dig in deeply and show you some of the code that goes along with it. Even for a relatively small application, there's a fair number of moving parts here. There's HTML, there's Python, there's JavaScript, there's Vue.js specific JavaScript, and Vue.js specific templates. I'm not going to go through all of that. For the most part, I'm going to concentrate on the server-side Python and some of the JavaScript. In particular, I want to highlight the parts where the DRF is interacted with, and then some integral parts of the JavaScript inside of the Vue pieces on the client side. The site you're watching this on, of course, isn't called Real JavaScript, it's called Real Python. So if you're not familiar with JavaScript, this could be a little bit painful. The expectation here isn't for you to understand every little bit and piece, but just to get a high-level view of how the parts fit together. Don't forget, all of this is available inside of the supplementary materials, and you can play with it on your own if it helps you understand. If you're going to run the sample code for yourself, you're going to need a couple things. First off, you'll need to install the dependencies. The dependencies are listed inside of requirements.txt. In order to keep your Python environment clean, it's best practice to use a virtual environment for this. You can install all of the requirements.txt file by using the -r parameter to the pip install command. This will take everything inside of the text file and install all of it. Inside of the SCED directory, you'll find a shell script that you can use to create the database, do the migrations, and set everything up. This is a bash shell script. It will only work if you are using some sort of Unix derivative. So if you're on a Mac, on Linux, or you're using the Windows Linux subsystem, then you can use this command as a shortcut. Here's the contents of that script. If you happen to be running on regular Windows and you can't use this script, then type these 6 commands in and you'll be good to go. Actually, you'll only need the last 4, because if you've got a brand new environment, there won't be any PYC files or a SQLite file to get rid of. The first command, wipe migrations, comes out of Django all. It destroys any migration files. I use this command when I'm playing with a brand new project, so that I don't create overly complicated chains of migration history when I don't really care about the migration history because I haven't gone into production yet. So it starts me clean each time. Then make migrations and migrate will set up and run your database, and then load data is used to grab the sample data for the timelines. The first half of this script gets rid of anything that's there already, so if you play around and you want to start from scratch, run the script again. Let me show you what this application looks like in the browser before I show you the code. Off screen, I'm running the Django dev server, and here I'm going to hit the home page of localhost port 8000. Here's the first of my 2 pages of my single-page application. This one is a standard Django view that spits out a simple bootstrap listing of the timelines that are in the database. Clicking on Peru takes me into the second page of my single-page application, and this one's a little more SPA-ish. This is built with Vue.js. Each row in the schedule corresponds to an item in the database. All of the rows are being sent down via JSON, and then interpreted by Vue.js. I can click the Add button, and get a pop-up for entering new information. This pop-up is one of the Bootstrap modal pop-ups coming from that library that I told you about. The pop-up is REST aware. This form inherits from a base class that knows how to create things in REST. It uses the names of the fields inside of the form and populates an AJAX call up to the server with a post method. By doing this, I need very little code to be able to create new objects on the server. I just need the form to create them and to make sure that the name attributes of the form are properly set. Submitting the form does a call to the server and updates what's on the screen. Clicking on one of these objects pops up the same form. Now the same form can be used to do an update. The Bootstrap modal library takes care of all of this for you. Clicking the delete button brings up a confirmation dialog. These dialogs are also part of Bootstrap modal. If I click yes, then a JavaScript function is called, calling this REST delete on the object in question. I'll show you the code to that shortly. And finally, this application is drag and drop enabled. The handles on the left-hand side of the screen allow me to change the order of the items. This no longer follows the movie, but you see what I'm talking about. The movement updates the rank of the item affecting the order on the server, and this has to be done with a custom action in order to take advantage of how ranked models work. Here are the models for the application. There's two things in the database, one which is a timeline, which is named and groups a series of entries, and the other is the entries. Line 6 through 10 defines the timeline, and the entry object starts on line 12. Let me just scroll down here for you. The entry has 4 fields. 3 of them are defined here, title, length, and the timeline that's associated with it. And the 4th is hidden in the abstract model called ranked model. The ranked model contains a field called rank. This is an integer that is 1 or more and indicates the order of the entry. Inside of the meta class, I specify the ordering as the rank field to make sure that when these are queried, they come back in rank order. Here's the views file that defines the 2 pages in my single page application. Line 6 is the home page that lists all of the timelines, and line 14 boots up the single page application part of this single page application. The edit timeline view takes an ID, which is the timeline that is being edited, and then it renders the editTimeline.html file. That file, amongst other things, contains the information that Vue.js needs to render the page. Up until now, I've been showing you the core app, which is for the timelines. I've also created another app called the API. I'm grouping all of the things that will be available through REST inside of the Django API app. That includes the serializers.py file. Inside of the serializers file, I have 2 serializers, one for the timelines and one for the entries. The timeline serializer contains the entries within it, so I'm nesting entry objects inside of the timeline. Here's another use of the source attribute. The name entry set might be a little confusing inside of the HTML or for anyone who isn't familiar with Django. So I've changed the serializer to call the entries entries. The entry serializer then has the source parameter of entry set, telling the DRF that the entries field should be populated based on entry set of the timeline. Because there are multiple entries, many is set to true, and so that I can create a timeline without specifying and serializing entries to go with it, I've set read-only equal to true as well. The entry itself contains the ID and the URL of the entry, the title, length, and rank of the entry. It also contains the timeline field. This will be the ID of the foreign key of the timeline object. This is necessary because you can't have an entry without it pointing at a timeline. So when you go to create a new entry, you're going to need that timeline ID. Inside of the API views file, I define the view sets for the DRF views that I'm going to use in the application. The first 2 items here are the vanilla view sets for the timeline and the entry. I've specified their corresponding serializer classes and the corresponding query sets. Let me just scroll down. The abstract ranked model class has logic inside of it that ensures that the ranks stay in order. The logic of all of this is done inside of an overridden save method. The DRF does not call the save method on an object. It directly updates the database. Any logic in an overridden save is not going to get executed. As a result, I've defined a new view here that is specific to changing the rank. I'm not going to use the built-in update methods of the DRF. I'm going to update it myself manually to ensure that the entries save method gets called. Except for this being a special case as to why I'm doing it, the rest of it is a view like you've seen before. I'm using the API view decorator to indicate that this is a get. This is a little hackish. To be more technically correct, I probably should have made this a put or a patch because I am editing an entry. but the URL that I'm going to be using for change rank will include the ID of the entry and its new rank. Because I'm doing this inside of the URL, I'm sticking with a get. This is one of those many cases where REST is kind of a suggestion rather than a rule. Using the entry ID, I get the object. I change the rank to the new rank provided and call the overridden save. I then requery all of the entries that are associated with this timeline and serialize them, sending them back down. This means when a move has been executed, the View application can get all the data at once as to what the new ranks are of all the entries that were affected. This is part of the Edit Timelines HTML file. The script body block is where all of the JavaScript pieces get set up. The key to interfacing with the DRF is passing a URL that specifies the timeline REST API action point to the View code. I've done this through the URL tag when this page gets rendered. The tag returns the timeline point for the REST view and sets that URL inside of the JavaScript global variable fetch URL. The View.js application will then use this to fetch the payload and populate the page. The remainder of this block is the loading of a variety of JavaScript files, including those to do the Bootstrap modals dialogues, a utilities function that deals with CSRF prevention, the actual View.js application inside of timelines.js, and a third-party library that allows me to do drag and drop with View.js. This is the timelines.js file. This is where the master object for View.js is created. That's on line 4, and it's put in a variable called VM. You'll see the use of that variable throughout this file. In lines 8 through 11, I create the data for the View.js object. HasLoaded is used to indicate whether or not the screen should be rendered yet. Timeline ID, name, and entries are all the JSON that come from the server. Timeline ID and name being from the timeline object, and entries being the array of JSON that specify the entries on the display. Django has a whole bunch of security mechanisms built in, one of which is to prevent problems with form posts. This is done through the CSRF token. The AJAX setup and getCookie methods come out of the utilities.js file and are used to make sure that a post can happen. All Django posts must include a CSRF token, so this little bit of code gets that token in the right place. Once everything's loaded on the page, the last call here is to refresh view. This method is what actually does the REST call. Inside of refresh view, I use jQuery's getJSON method, passing in that global fetch URL variable. GetJSON takes a response function, and inside the body of that response function, I'm setting up the View.js data attributes. Timeline ID and name both come out of the response field from the timeline object, and entries is copied from the array of entries. Once those three values have been put inside of the View.js object, I set HasLoaded to true to get the screen to render. The View.js template that is rendered included the add button. There's a hook on the add button that says when the button is pushed, call the method addEntry. That's defined here on line 14. Inside of the add entry, I create a dictionary that contains the ID of the timeline object for the entry that's being created and a rank. The rank is set to be one more than the last rank currently in the listing. The Bootstrap modals library has a way of declaring forms and using REST methods to update objects that are associated with them. In line 22, I'm using the change form, which you saw that was popped up when you hit the add button, and I'm calling the showCreate method on this form. ShowCreate knows how to talk to REST using a URL, doing a post, creating a new object. The first parameter to this method is the URL of the post, API v1 entries, because I'm creating a new entry. The second parameter is the default data for the dialog box that's being popped up. The dialog has two hidden fields, which are the timeline and the rank, and then the two fields that you saw, the title and the length. That populates the dialog box. When the user hits save, the server is contacted by the Bootstrap modal library, the REST post is done, the object is created, and then the third parameter of showCreate is a callback. The response contains the newly created object. vm.entries.splice is a way of taking that response object and gluing the result into the entries listing on the View.js object. This adds the newly created entry to the list on the screen. Edit entry works in a similar fashion. Once again using the same form, this time calling a method called showPatch. ShowPatch takes the URL of the entry that was passed down as included as part of the JSON payload, the entry object itself, which it uses to populate the form, and then when the user hits OK in the dialog box, a patch is issued to the server. The REST code is triggered, the entry is updated. The third parameter to show patch is once again a callback. Once the entry has been patched, the server responds with the updated entry. The View.js VM object has the entries array spliced, replacing the old entry with the new one that was just edited. You saw on the screen that I'm using a third-party library for View.js called Draggable. The Draggable library comes with its own tag, and inside of that tag, I have specified that when a drag action completes, that this method entryMoved gets called. You'll recall that I don't want to just call patch here on the rank number because I need the object's save method to get called on the server. So I'm calling a specific custom REST action instead. I do that by using jQuery's getJSON. The URL is the change rank URL that I showed you earlier, complete with the ID of the entry that's being changed and its new rank. And getJSON has a callback. And I take all of the entries that come back from the change rank and replace the client-side copy. Similar to the add button, each delete button is also wired to a function. That's this delete entry method. Inside of that, I'm using another dialog box out of the Bootstrap modals library called confirm. Confirm shows a title and whatever text you give it and presents a yes and no button. Then it has a callback mechanism that checks whether or not the user hit yes or no. On line 52, I look for a negative result and do nothing. The REST call happens on line 56. If you get here, then the person hit yes. It takes the entry object on the client side, grabs the URL, and does a straightforward AJAX call using HTTP delete on that URL. The object has now been deleted on the server side. There were a lot of moving pieces in that. I hope it wasn't overwhelming. My intent was just to give you a flavor of how the REST pieces can be used inside of a single-page application. If you're truly interested in how all those pieces work, you'll probably want to dig into the sample code and walk through it yourself. Next up, the last lesson, summary of everything you've learned. In the previous lesson, I showed you a sample single-page application. In this final lesson, I'll summarize what you've learned. REST is a loosely defined protocol that allows you to list, create, update, patch, and delete data on your server. It uses existing HTTP methods and URLs to perform the actions. The Django REST framework, or DRF, works in conjunction with Django to perform REST activities on top of Django model objects and views. Inside DRF, the serializers are responsible for turning your data into payloads and taking payloads and turning them into your data. The model serializer maps Django ORM objects. This means it takes very little code to convert something you've already got into a payload. Objects with relationships on the server side can be serialized together and nested into parent objects. Although the most common use of serialization is to serialize Django ORM objects, DRF serializers are able to serialize generic Python classes. You can pretty much serialize or deserialize almost anything that you want. You implement a REST endpoint with a view on the Django side. The DRF provides decorators to wrap your views and REST response objects that know how to work with the serializers. In addition to the views, the DRF provides a series of classes called ViewSets. These classes group together multiple HTTP methods or REST actions and manage them together. This is particularly useful when you're serializing a Django ORM object. You can create a view set that has all of the REST action points for that ORM object in just a few lines of code. You can create a DRF router object to register one or more view sets, and it will automatically map that view set to the necessary URL patterns. You can manage who sees what data and what they're allowed to do with it by specifying permissions and query sets associated with a view set. You can also add custom actions to a view set in order to augment the base REST calls. The DRF response object takes information out of the serializer and turns it into a payload. It does this through a renderer. DRF supports several different ways of rendering your data. By default, it gives both a JSON and a web-based interface for your payloads. You can also control which renderer is being used and how things are rendered through changing settings or decorators of your views. For further reading and minutiae on the DRF, go to the Django REST Framework website. The website also maintains a huge list of third-party packages that may already implement that corner case that you've been worried about. Take a look at this URL for more information. I hope this course has been valuable to you. Thanks for your attention.